Hi students, welcome to another session. This is Avilas, your chemistry faculty, and today we'll be discussing one of the most important name reaction, that is Cannizzaro's reaction, and which comes from aldehyde ketone and carboxylic acid chapter. And in previous year, several JEE and NEET exams, this question already came. So basically, this is one of the most important question from your JEE perspective as well as from your NEET perspective. So we'll be discussing about this particular reaction in detail. That will be discussing what are the reaction conditions you need, what is the how the mechanism works, as well as what type of products you will be getting at the end. And at the end, we'll be solving few previous year questions as well. And I'm sure that that at the end of this video, you are going to by heart all these things definitely. So let's start. So basically, what happens in Cannizaro's reaction, that when any aldehyde containing no alpha hydrogen, without any alpha hydrogen, will react with strong or concentrated base, then what happens actually? It undergoes disproportionation reaction. And when it undergoes disproportionation reaction, that means the reactant at the same time will be oxidized into one product and will be reduced into another product. So we'll see that when aldehyde is getting oxidized, it is getting converted into carboxylic acid, and when aldehyde is getting reduced, it is getting converted into an alcohol. So we'll be discussing how you will be getting this carboxylic acid and alcohol through our mechanism. So basically, here what you need an aldehyde, you need an aldehyde with no alpha hydrogen. First most important thing, that you need an aldehyde with no alpha hydrogen. Then concentrated concentrated base. And most of the time we use, you will see there will be sodium hydroxide or KOH most of the time. And sometimes also it is written, you will see that 50% KOH or 50% NaOH, like that. So 50% means it is concentrated, you can consider as concentrated, no problem. Okay, so here you need an aldehyde with no alpha hydrogen and concentrated base or alkali. So here what is an aldehyde without any alpha hydrogen? First of all, we need to know this thing, that when any aldehyde, when any aldehyde which doesn't contain any alpha hydrogen. So what is this alpha hydrogen? So when functional group, the carbon atom which is directly attached to the functional group is known as alpha carbon. So if here CHO is my functional group, then this carbon will be my alpha carbon. And at this carbon, whatever hydrogens will be there, that will be considered as your alpha hydrogen. So let's say here three hydrogen atoms are there, CH3CHO acetaldehyde. Then we can say these three hydrogens can be considered as alpha hydrogen. So here we don't need this type of aldehyde, we need that type of aldehyde which can uh, have no alpha hydrogen. So here we'll not consider this particular reactant. So what type of reactant we'll consider? Let's see. So you can take you can take benzaldehyde, you can take formaldehyde. Here if you'll see, if this is your functional group, then the carbon which is attached to this functional group is your alpha, and at this alpha position there is no hydrogen. So this is an appropriate aldehyde which we need to carry forward our reaction, Cannizaro's reaction. Similarly here also, this is your functional group, and here this functional group is doesn't attach to any alpha carbon nor alpha hydrogen. Similarly, there are also different types of aldehydes which doesn't contain any alpha hydrogen, you can also consider this particular example as well, that here also the this but at this particular alpha position there is no hydrogen. So these are the different types of aldehydes you can consider for your Cannizaro's reaction. Okay, so what the next thing, if you have listened properly in the beginning, I told it undergoes disproportionation reaction. It undergoes disproportionation reaction. So here disproportionation reaction means one reactant simultaneously will be oxidized as well as will be reduced, which is known as disproportionation reaction, or in short you can also tell it as, consider it as redox reaction. So here who is undergoing redox reaction then? Who is undergoing redox reaction? So if you'll see here, what we are taking, we are taking aldehyde. We are taking aldehyde. So aldehyde will undergo oxidation, and you know when aldehyde undergoes oxidation, it will be converted into respective carboxylic acid. Here what is happening? Oxygen content is increasing. Oxygen content is increasing. And when aldehyde will undergo reduction, it will be converted into an alcohol. And here what is happening? Here hydrogen content is increasing, and you know increase in oxygen content is oxidation, increase in hydrogen content is reduction. So here, okay, so here what we are getting? One carboxylic acid and one alcohol from aldehyde which doesn't contain any alpha hydrogen. So let's see. So if we'll consider this aldehyde formaldehyde, okay. So what will happen? That when formaldehyde will react with a base, let's say sodium hydroxide concentrated. So what will happen here? That this aldehyde will be oxidized as well as reduced. So when it will be oxidized, it will give you HCOO minus Na plus plus CH3OH. And here, this is what? Your oxidized product, and this is sodium formate. And this is what? Methyl alcohol. So you are getting one oxidized product and one reduced product. Here oxygen content is increasing and here hydrogen content is increasing. So how this particular uh, reaction occurs? So let's see the mechanism. Okay, so see, I'll be removing all these things. Okay, okay. So now we'll see our mechanism, how it works. Okay, so here in the first step, what happens? That the nucleophile will attack to the carbonyl carbon. So here we can say in short that nucleophilic attack is occurring. So here if you'll see what we have taken initially, formaldehyde. So what will happen? That OH minus, because we have taken sodium hydroxide, and sodium hydroxide will be separated into Na plus and OH minus, and that OH minus will act as a base. And what base does? What base does generally? Base abstracts proton. Which proton? Active proton. What is active proton? That proton which is attached to any electronegative atom like fluorine, oxygen, nitrogen, any halogen, like that, or any hydrogen atom which is attached to a carbon atom, which and that carbon atom is attached to an electron withdrawing group, strong electron withdrawing group. Then in that case also that hydrogen will be active. But here there is no such type of case that this base can abstract the proton. So as here base can't abstract the proton, so it will act as your nucleophile. So what will happen when it acts as nucleophile in front of your carbonyl group? So what happens that this carbonyl C double bond O will break towards oxygen, and this OH minus will come and attack at carbonyl carbon. So what you will get? You will get CO minus, and here H, and here OH. Okay, and this particular uh, species, this particular intermediate species, what we have got now in the first step, this is known as hydroxy hydroxy alkoxide. Alkoxide. Why it is hydroxy alkoxide? Because OH group is there. That's why hydroxy. And why it is alkoxide? Because R, alkoxide is RO minus, and here also this is what? If I'll consider this as my R, then this is your O minus. So RO minus. So this is a derivative of RO minus because your OH is attached. So that's why it is hydroxy alkoxide. So here we have got an intermediate, that is what? Hydroxy alkoxide. Then in the second step, what will happen? Then second step, what happens? That hydride transfer will occur. Hydride transfer. So how this hydride transfer will occur? Let's see. So here what we have got, hydroxy alkoxide, from that only will start our reaction. Minus H, and this is your OH. And here what will happen, that it will react with another molecule, another mole of aldehyde. Okay. So here what will happen, that hydride transfer. What is hydride? Hydride is basically H minus. Hydride is basically H minus. See, meanwhile, through this reaction, while discussing this reaction, I'll be giving you lots of information regarding other things also. So see, generally, you know that whenever a negative charge comes over any other atom, then we use the suffix IDE, ide. Let's say it is negative charge over oxygen, oxide. Then your negative charge over halogen, halide, like fluoride, chloride, bromide, iodide. Similarly, nitride, similarly, phosphide, similarly, carbide. Similarly, when negative charge comes over hydrogen, it is hydride. So here what will happen? Hydride transfer means H will be transferred in the form of H minus. So how it will be possible? So here generally, most important thing, remember, we use this hydride transfer rule where we need to form a more stable carbocation, or we have to stabilize the carbocation. So here what is happening, that here this negative charge, if we can neutralize this negative charge, then it will be more stable. So how we can neutralize? If a positive charge will come over here, how this positive charge will come over here? When we'll break this bond towards hydrogen. So here what will happen, this hydrogen will be after the breaking of this bond, will be shifted to this carbonyl carbon as a H minus. So here what will happen, this plus minus will make the double bond. So what you will get here? You will get what you will get here? You will get here that C O minus H H and another H, and this H came from this one. This is that H, and here along with that, what you'll be getting? H C double bond O OH. So what you have got? You have got carboxylic acid and one alkoxide ion, CH3O minus. This is known as methoxide. This is known as your methoxide. Okay, and remember, this particular step is the slowest step of this reaction, and also this is the rate determining step, because generally we used to find the rate from the slowest step of the reaction, and this is what? This is your first step. Okay, now here in the third step, what happens? Proton transfer occurs. What happened? Proton transfer. Second step, hydride transfer, and third step, proton transfer. How? So here this methoxide CH3O minus, now this will act as a base. This will act as a base, and base can abstract active hydrogen. Recently I told. So here another reactant that you are getting, HCOH. This is what? Carboxylic acid plus your CH3O minus. So this base, what it will do? It will abstract this proton. How? When this bond will break towards this oxygen, you will get what? H plus. So what you will get? HCOO minus plus CH3OH. So what you have got? You have got an alcohol, and you have got one carboxylate ion or anion, as negative charge is here. And here remember, we have started our reaction from sodium hydroxide, so here it will be sodium formate. Here it will be sodium formate. If you have taken here potassium hydroxide, then it will be potassium formate, like that. This is your oxidized product, and this is your reduced product. Remember. And in exam, most of the time question comes that in Cannizzaro's reaction, which step is your rate determining step? So hydride transfer step is your rate determining step. Got it? Okay. Then again, if the examiner will give you here H3O plus, means acidic hydrolysis, then in presence of H3O plus, what it will do? This carboxylate ion will be converted into carboxylic acid. So what will happen? That here generally hydrolysis means breaking in presence of water. So here what will happen? This will, as you know, it is in ionic state. So this side H plus will come, and this side OH minus. So you will get HCOOH, formic acid. This is what? Your formic acid. So this is what the mechanism of your Cannizzaro reaction. So now I'll be discussing all these things, and we'll be doing some more questions. So see, let's say, just a moment, just a minute. Okay. Okay. See, so here what we'll be doing here, we'll be discussing some of the uh, some more questions. So see, Let's say here you are taking benzaldehyde. What you are taking? Benzaldehyde. And you are treating this with, let's say, 50% KOH. I have already told that 50% KOH will also be considered as your concentrated base. So here, what will happen? That this aldehyde, first you have to check whenever base is there. You have to first check whether alpha hydrogen is there or not. If alpha hydrogen is there, then it will undergo aldol or any other reaction. And if alpha hydrogen is not there, Cannizzaro. So now see, this is aromatic aldehyde, benzaldehyde, and here at this particular position, there is no alpha hydrogen, because if I'll remove these bonds, if I'll put these bonds, then here at this particular position, this carbon has already formed 4 bonds, so there is no place for hydrogen. So it satisfies all the conditions for Cannizzaro reaction. So what we'll be getting? We'll be getting two products. One product will be oxidized, another will be reduced. So the oxidized product will be what? Your COO minus K plus plus. Another product will be reduced product, that is your alcohol. So what you have to do? The trick is, whatever carbon is there, the carbon atom of the functional group of aldehyde, that you have to convert into carboxylate anion as well as alcohol, CH2OH. Remember, CH2OH. That's all. Similarly, let's say here, this is the case, CHO, and it reacts with, let's say, concentrated sodium hydroxide. Sometimes also you will see like concentrated 50%, nothing will be given, only sodium hydroxide, let's say, it is given. So how to determine which reaction? So as here alpha hydrogen is not there, so it will follow Cannizzaro reaction. You have to consider. So now what it will undergo? Same Cannizzaro. So one you will get CO minus Na plus oxidized product, and another one you will get reduced product, means CH2OH. Got it, all of you? Okay. Now see the next thing. Let's say it is given formaldehyde and benzaldehyde. Then in this case, two different aldehydes are given which contains no alpha hydrogen. Then in this case, what you have to do? Generally, students get confused at this particular point, that when cross Cannizzaro reaction will come into picture, then which one you have to oxidize and which one you have to reduce. Most important thing. And it is so simple that what you have to do, always remember that among aldehydes or in any carbonyl compounds, when the nucleophilic addition reaction comes into picture, then in that case, the nucleophile always attached to that carbonyl which is more reactive. So how you can say which is more reactive? So generally, if you'll see the characteristic, the chemistry of carbonyl group, that because of the higher electronegativity of oxygen atom, this carbon oxygen bond always gets broken towards oxygen. So here there will be formation of partial positive charge, and here there will be formation of partial negative charge. And when this bond breaks, it is having positive charge, partial positive charge. That means positive charge is favorable for the attack of nucleophile, so that means we can say that if more will be the positive charge here, then nucleophile attack nucleophile attack will be more easy, isn't it? Will be more easy. So this is one condition, that electropositivity electropositivity at carbonyl carbon increases the reactivity. isn't it? Reactivity for what? For nucleophilic addition reaction. And one more thing, that steric crowding or steric repulsion. That here if you'll see in in formaldehyde, only two hydrogen atoms are there at two positions at both sides. But here if you'll see this benzaldehyde, at one side there is a very big ring, phenyl ring, so which is more bulkier than this hydrogen, so which will restrict the further coming of nucleophile. So that's why steric crowding also matters a lot. So in between these two, after combining all these two effects, what we are observing, that this formaldehyde is more reactive towards nucleophilic addition reaction. So that means in the first step, OH minus will attack to that carbonyl carbon which is more reactive towards your nucleophilic addition reaction. Are you getting what I'm saying? Now here what will happen, that OH minus will attack to whom? To this carbon. That means at first step, OH minus, when to which particular reactant OH minus will attack, that will be converted into your carboxylic acid or carboxylate anion. That means which is more reactive, which is more reactive towards nucleophilic addition reaction will be oxidized, into COO minus. So here what will happen, this formaldehyde will be oxidized, means formate ion, so you will get HCOO minus, and here we have taken NaOH, so HCO minus Na plus this benzaldehyde will be reduced. That means this benzaldehyde will be converted into CH2OH. Got it? So what we have got, that in case of crossed Cannizzaro's reaction, what is happening, that when which is more reactive towards nucleophilic addition reaction, that is undergoing oxidation, and the another one is undergoing reduction. So in this case, it is now so easy to find the product. So now let us see some more questions that here we'll see. Now see here. So this question came in AIPMD 2003, and also this question came in IIT also. Okay, when metachlorobenzaldehyde is treated with 50% KOH solution, the products obtained is or are what? Metachlorobenzaldehyde. So what is this metachlorobenzaldehyde? So first we'll write benzaldehyde, then at a meta position chlorine is there, and it is reacting with whom? 50% KOH. 50% KOH. So now what will be the product here? Which product will get? See here, this aldehyde doesn't contain any alpha hydrogen. That means it will undergo Cannizzaro. Cannizzaro means will disproportionate into two products, carboxylate anion and alcohol. So here one product will get, you will get COO minus Cl plus. Another product will be your CH2OH and here Cl at meta position. So here let's see, here OH is OH is coming into pictures. It is not nucleophilic substitution reaction, and you know in benzene ring also nucleophilic substitution is very difficult. So here this will not be your answer. This will not be your answer, because here nucleophilic substitution reaction also occurs, and nucleophilic this doesn't follow nucleophilic substitution reaction. Got it? Now in between these two product, Here what is happening? Here condensation, and here in Cannizaro's reaction we don't see any condensation reaction. It is disproportionation reaction, means same reactant will be oxidized and reduced. So here this will also not be your answer. So the one product will be this one. See, in exam most of the time, how easily you can eliminate the options, easily you will get the answers. So only you have to, what you have to do in organic chemistry, you have to first get the concept. What concept I can apply here? Which concept? Once you got the concept, then just think about the product. That type of product you have to look for in the reactants, and definitely you can eliminate the options very easily if you have observed the correct concept. Now let's go to another question. Okay. Okay, this is another question. So now see here what is happening, that this question came in AIMS 2015. Okay, see, so here this is one aldehyde which doesn't contain any alpha hydrogen, and here what is happening, this is intramolecular Cannizzaro. This is what? Intramolecular Cannizaros. So here what will happen? The same thing. Aldehyde will be disproportionate into two products. One will be acid, another one will be alcohol. So now see here, this benzene ring contains two CHO group. This benzene ring contains two CHO groups. So one will be oxidized, another one will be reduced. If one will be oxidized, that means it will be COOH. Another one will be reduced, means CH2OH. Now here, what is happening? Here, if you'll see, here CH2OH, 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 only one COH. Not correct, because one will be oxidized, another one will be reduced. But here both has been reduced. So this will not be your answer. Then here, if you'll see here, this one, that here all are oxidized, will not be your answer. Then here, between 1 and 4, 1 will be your answer. But the thing is, here if you'll see, here sodium hydroxide first. So what you will get? CO minus and CH2OH. Got it? Then acidic hydrolysis. If you have observed our mechanism properly, then when you will when you will do acidic hydrolysis, that COO minus carboxylate anion will be hydrolyzed into COOH. So here what will happen? That here it will remain as it is, COOH, CH2OH, COOH, CH2OH. And this will not undergo any cyclization reaction. This will not undergo any cyclization reaction. Normal, you got what? What you have got? You have got one COO minus and another one will be CH2OH, and here also similarly one will be CO minus, another one will be CH2OH. And when you will treat this with H3O plus, then what will get? This CO minus will be converted into COH, and this one will be CH2OH. And here same thing will happen, that here this CO minus will be converted into COH and it will be CH2OH. So you got your answer. So I hope, like in this session, you have got how Cannizaro's reaction is happening and what type of product you are getting. Always you have to look for that base, concentrated base, no alpha hydrogen, then Cannizzaro, then disproportionation. One will be oxidized, another one will be reduced. Then comes the second part, little bit advanced, that who will be oxidized, who will be reduced. That which is more, reactive towards nucleophilic addition reaction, that will be oxidized, and the another one will be reduced. Okay, so now with final one question we will end this session, that let's say here there is an aldehyde, there is another aldehyde CHO, but here NO2 group is there, and it will react with sodium hydroxide. Then what will happen here? Who will be oxidized, who will be reduced? Which is more reactive towards nucleophilic addition reaction. So here, both are aldehyde, but the difference is here it contains one electron with heteroene group, which is here acting as minus I group as well as minus M group. And here it will increase the electropositive character of this carbon, electropositive character of this carbon. So as it will increase the electropositive character, so the nucleophile attack will be more easy in this case. So as it is more reactive towards nucleophilic addition, so this will be oxidized, this one will be oxidized. So the product, what you will get? You will get COO minus Na plus plus NO2, and another product will be CH2OH normal. So this one will be reduced and this one will be oxidized. I hope all of you have got this particular concept for Cannizzaro's reaction. So if there is any doubt, you can put it in the comment box. Okay, thank you everyone, thank you.